resistance, it will be working fine. Even if you are putting the emitter maybe before the resistance, then also it is fine because it is a series connection, right? In the reverse bias, we are going to just reverse the diode location, thing, or you can just reverse the battery. So that is going to give you the reverse bias. Now the procedure is given how you have to complete it. First of all, you have to set the DC voltage to you may start with 0.2, 0.4 like that. Then you have to select the diode, silicon type or germanium type. Set the resistor, which is the safety resistance I told you, right? Voltmeter is placed parallel to the silicon diode, and ammeter is placed in series. So let's go to the simulation now. So this is the simulation. I'm going to this, open the simulation part.
नहीं दिख रहा ना पीपीटी में प्रॉब्लम है मैम का नेट का इशू है लेकिन मैम मानती हैं
Should I put in chat?
ठीक है एक बार यूट्यूब ओपन करना
Done. So once you have opened this, there are multiple options: forward bias, reverse bias, silicon diode, germanium diode, and all. So what you are expected to do is, first let us do the first one. So the first one is forward bias silicon diode. Click on that. Once you are going to click on that, it is going to give you something like, is my screen visible to you people? Yes, please. Screen is not visible.
No.
आप बोल दो ना मैं कर लेते हम स्क्रीन नॉट शेयर करें
Ma'am, can you please share your screen again?
Can you please? Yeah. Done.
It's not visible yet.
visible
Okay, visible, yes.
Okay. Okay. So just a minute. Fine. So this is the screen we are having. Forward bias silicon diode. Just click on this. You are having this circuit. This is the circuit which you are expected to draw. Now in the back to this. Now this is forward bias silicon diode. Draw the circuit. Click on the draw the circuit. Now you are going to draw the circuit. It is just like whatever you were going to prepare in your breadboard. So whatever we have learned in the previous one, like the circuit should be somewhat like this. It should look somewhat like this, right? So we will be doing the connections according to this. We can see the resistance is connected to the emitter. Then the emitter is connected to both voltmeter and diode, and voltmeter and diode other terminals are connected to ground along with battery, and the battery terminal and the resistance are connected. We can learn from here, or instructions are given. Just click on the instructions. Do not click. Just take your cursor to the instructions left hand side. When you will go over there, it is written that what you have to connect with what. So for example, the first one, it is given connect the components as mentioned. L1, it is the name. L1 means it is a terminal. 1, 2, 3, 4, 5 like this. The things are given, nodes are given. So L1 you have to connect with L3, L4 with L7, L8 with L10, and like that. So first of all, let us click the connections on the connections. When you are going to click over here, it is, and then drag it. You have to click and then drag. So it is going to join. Likewise, 4 to 7, you are going to complete the connection in this way, right? And then this is the ground. You are going to make the ground. Power supply from here, and the 6 terminal. Just have a look at this. 6 terminal is getting connected to 11 terminal. So 6 terminal is getting connected to the 11 terminal and 5 terminal is getting connected to the 10 terminal. So now I have done the connections. Have you completed the connections? Please type yes in the chat box if you have completed the connections. Type Y in the chat box if you have completed the connections. Nice, good. You may type Y in the chat box if you have completed the connections. Shall I proceed? Please type Y if you want me to proceed. Okay, so let's proceed. So what you have to do after the connections, just click on the check the connections. Okay, thanks. So click on the check the connections. So I'm going to click on this. It is going to say wrong connections. Something I have made, something I have made wrong. So I have to check the connections again. So
इसमें
I
जो
will check
दूसरा
the
काम है
instructions.
करता है
L1 was connected to L3, yes. 4
अभी
was
नहीं,
connected to 7, yes.
दूसरा सिस्टम
कल
काम
8
करता
and
से
10 were
वहाँ
connected,
करेंगे एक बार
yes.
बैठ जाना
है।
पूरा समय मैम का ही रुकू
5
करेगा
and 10 were
ये मैं
also
पूछ रही
connected.
हूँ
5 and 10,
कल
yes.
लेना
6 and 11,
मैम का
9 and
ये
11,
6 to
6 and
7
11.
तक
Okay, 9 and 11 were
9
connected.
PM
I
to
have
come to 1
connected
o'clock फिर मैं
9
बैठ
and
जाऊंगी
12.
ये मैनेज कर
So
पाए
that's what it is missing. So
जस्ट
9 and
मैम को
11 I
आपको
have
लिख
connected. I have not
दूंगी जस्ट
connected 9
इन
and
फर्स्ट
11.
ओनली शी आस्क्ड
So
वेदर माय स्क्रीन इज
there
विजिबल
is an option delete
अगेन
connection.
आपका
You can
नंबर
see here it is the delete connection. So just click on this. Once you
अटेंडेंस
are going
उसी
to click
समय
on this,
उठाना
it is
बिकॉज
going to reset
मॉर्निंग
everything again.
मॉर्निंग में
So
समटाइम
now
कुछ
again do the connections
इसमें नहीं हो रहा
as per the requirements.
दोनों
So there
फैमिली
was a missing
बिकॉज
thing that
इट
this
वाज
and
टिल
this,
5
these
o'clock
are
मैम
connected,
ने
this
शिफ्ट कर
and
दिया
this is
कुछ नीट का
connected.
एग्जाम
मीट का
ऐसा
एग्जाम है
था
कल
तो
It
इसलिए
was 9, 11, 9,
ऐसे तो
12, right?
रमेश इसका
9,
नाम
11
सेकंड
as well and
हाँ
9,
रमेश
12
है
as well.
बट मैं तो मॉर्निंग से नाइट तक रहूँगा
And from 11 it is
नीट
6.
का
अवेलेबल रहना ही मेरे को
11,
ओके
9 and 11, 6.
फिर आप
So it
संभाल
is
दीजिए ना इसका थोड़ा थैंक यू
11, 9, 11, 6, 8 to 10 and 4 to 7. Yes, these are connected. Now I'm going to check whether it is fine. So check the connection. So the right connection, the window is going to appear over here. You can see it on the screen. It is going to show that the connections are correct. If the connections are correct, we can proceed for the next part. So let's proceed for the next part. Click OK over here. Once you are clicking OK, what you have to do, so in instructions you can go if you forgot something. Once the connections, we are at third number instruction. If connection is wrong, double click and then delete all, and then you have to do it again. Now what you have to do, uh, we have to set the DC voltage and then we have to set the resistance. So set the DC voltage 0.2. So keep on checking the DC voltage. So DC is the power supply voltage. You can look it over here. VDC in the circuit, it is showing as you are scrolling this DC voltage bar line, it is going to show you 0.2 volt DC voltage. Now what you have to do, you have to set the resistance. So let me check the resistance. So this, let us check, set it 1 kilo. So I have set it to 1 kilo. If it is not done, you have to do it precisely. Okay, it is not making it 1 kilo. Yeah, it's somewhat like this. So now it is 1 kilo. Now check the next instruction. What is this? Voltmeter is placed parallel to the silicon and emitter with series. The positive side of the battery. Yes, everything we have done. Now what you have to do, vary the voltage, keep on varying the voltage and keep on finding how much current is going to flow. This is what we are expected to do now. So add to the table whatever values you have, add to the table. So in the forward bias the voltage is 0 and the current is also 0. Change the DC bias. So I have changed the DC bias 0.4 add to the table. Click on add to the table. So it is actually the reading is same because the forward bias voltage is from here, the diode voltage it is going to take. That 00 entry was already over there. In the experiments we used to use the third column in which DC power supply we used to put. So the DC power supply changed from zero point 0.2 volt to zero point 0.4 volt, but still we can see 00 readings are there. So when I am going to click on the add to the table, it is not getting added. The reason being the current is still sorry, voltage across the diode or the current not has changed. So now let me take it a little bit more. 6. As soon as I am going to make it 7 volt, so you can see the current the voltage across the diode has changed. So I'm going to make it in this way and then make it more, and you are having such readings. So in this, the readings are in place of current, it is going to give you NAN. This is because we have not selected the diode. So select the diode 1N4001. 1N4001 is the standard silicon diode which is having the voltage, that is threshold voltage is 0.6 volt. So it is going to give you VF is equal to 0.6 volt. Now the current will get added. So now when you are going to add this into the table, this is going to give you the current. For example, let me take it this.
English note edu kanisilla how many greens
0.5, then 0.6. At 0.6 also things are 0.
காட்டு அவன்கிட்ட
Now from 0.6 I am going to make it 0.7.
சரி
Yes, some current we are seeing. Then 0.8. Then point forward bias voltage 0.9. Okay. Then 1.0. Okay. 1.1. Okay. 1.2. Okay. 1.3. So likewise we are going to take 1.3, 1.4. I am going to increase it a little bit. 1.4, 1.5, 1.7 I have taken. 1.8, 2 volt, and so on and so forth. So if I am going to increase it more, what is going to happen is the voltage across the diode is getting dropped more. Okay. Now this is the table. Left hand side is the experimental table. Now we have to plot this graph. So come to scroll it down and you have to plot the graph. So in order to plot the graph, what you are expected to do, go to the instructions. In the instructions, it is take the readings and not the voltmeter reading across diode and this. Plot VI graph and observe the changes. So now you can plot the graph. Just click on plot the graph. It is not in plot. Yeah, it is here. Add table, just next to it there is plot. Just click on this and you are getting this. This line basically is the previous readings which were wrong readings. Because of wrong readings we got this graph, otherwise this is what the actual graph is. Okay, so let me take a snapshot of this so that I can show you that which part I'm talking about. So I'm talking about this is the part which actually with the with the wrong readings we used to in the starting 3-4 readings which were not really good readings, and this part is actually the actual performance of a diode. So we have taken the silicon diode and we have performed the experiment for the silicon diode. Now I request you to follow me again so that you can learn how it is completed using this virtual lab. Now how it is helpful, basically in your lab, maybe you, if you are the student, you might have done on the breadboard and with the help of discrete components. So what you people are going to do, And being a teacher also, if you are going to tell them, so they are going to take these type of readings, they are going to take these readings, they are making all these connections on the breadboard, they are going to take these readings, and since it is the hardware and they are actually in hurry, okay, we have to complete this experiment, this experiment, this experiment, they do not know much about the theory and all. Only one turn is there in the lab, and it has been observed by me in my basic electronics lab that they do not have much more knowledge about it. So this is not a replacement of the physical lab. Please remember, it is not a replacement of the physical lab. It is going to support the learning for both for the teacher and for the student. If the student is coming up with this simulation work, then it is good for him to understand the basic concept, that how the things are getting changed. For example, let me give you some details. The student do not understand in the table, this is the VD voltage, we are talking about this volt, right? Students do not understand this because while performing the experiments, so while performing the experiments, what they used to do is they used to fill this entry, okay, which is VD voltage. It is not VDC, it is the voltage across the diode. This entry is the VD voltage, that is voltage across the diode. And this entry is what? This entry is the current through the diode. That's what the IV characteristics of the diode we will be calling. But instead of taking the VD voltage, what they are going to take is they are going to use this reading. That is wrong. So if they are going to follow these experiments, it will be easy for them, and every student can have this because this is there on the virtual labs. There are most commonly used diodes are given over here in this lab. I can show it over here. For example, here I'm going to change the diode. So for example, I'm going to take 5408. So 5408, if I'm going to take, this is going to change the characteristics. Yeah. So let me take, maybe I need to do it again, then only it will work. It is not working with the same setup. So let me take the reverse bias. We have 5 minutes, then we will be having the LT Spice session. I hope you have installed LT Spice in your systems. So for reverse bias, I have taken it. The direct simulation part is going to appear. How you have to make the connection? So you can see the connections will remain same. Only the diode position is reversed. So go to the virtual labs, go to the silicon reverse bias draw circuit. So go to this, and now it is here. Choose the diode. All of these are silicon diodes. So I have taken the same diode. This is the diode. So VR is taken 30. You can actually change this VR also. VR means the reverse peak inverse voltage. So it means you are expected to keep it below that. You have to make the connection. So just have a look at this, and according to that you have to make the connections. L11 is connected to 6 and 9, and 9 is connected to 12 and 11. So 11 is connected to 6 and 9, this was the problem. Although the meaning was same, because this is prepared with the help of programming, so we cannot make all these
एक बार उनका
things
नाम बताना वो जो अभी
like
आने वाले हैं
we cannot expect that, okay, this is, if I am connecting 9 to 11 and 11 to 12, that's the same. Of course, that is same in the physical,
हाँ, उसमें
but
क्या
this
नाम है उनको
is
पहले से
actually
फोटो खींच के
programmed.
रख दो ना
So
कल
the
में
the
भी
minute change actually will
आपके पास
change
भी
the
दिया
other
ना
things.
schedule पूरा
So now let us put DC voltage a little bit, set
टॉपिक रख
the
दो हाँ
resistance.
करके रखो क्योंकि कभी
So
कभी
yeah,
जरूरत
this is the
पड़ता है
resistance. The same 1 kilo resistance I am going to set. So this is just 1%
इसका
difference.
माउस वगैरह नहीं
No
है
problem. Now keep on adding into the table. Whatever you are getting, you keep on adding. So this is one reading, another reading, add to the table, next reading, add to the table, next add to the table, and keep going on. So you can have a clause, look, microampere it is 0.1. For all of these it is 0.1. It's not going to increase. It will start increasing beyond 30 volts. But we cannot let that happen, because beyond 30 volt it will be the breakdown, which is known as the avalanche breakdown, right? So we are not going to take that reading.
9:30 में आ जाएंगे, 9 बजे तो हम लाइव करना स्टार्ट। और ये सर 9:30 पे आ जाएंगे।
So this is what it is done, and now you can plot it. So check connections. You have to check the connections very first, and then only you have to. So you can see the reverse bias, it is the straight line, because only the saturation current we will be having, and that too in microampere. So this is the straight line. It shows that the reverse bias current is 0, because it is 0.1 microamp, which is very less as compared to the forward bias current, which you can see from here. That was the forward bias current. Okay. So in the same category, if you want to add a little bit more, what you can do, you can change the resistance, and then you can see what variations you can have. So change the resistance, then again start the things adding from 0. So I have taken a few readings related to it. Yeah, and now I'm going to plot. So you can see over here, when I'm going to plot, this is the different curve I'm getting, the new curve along with the old curve. So it means with multiple resistances, you can have multiple graphs with the help of this. So it means this is very helpful for the students to understand, if I'm going to change the resistance, how this can actually give me the graph. So this is why it is important that you should practice itself, and it should be practiced by the students also, so that they can understand how is the behavior of a diode. Okay. So let us stop for this particular virtual lab session now, and the next session we will be starting on LT Spice. I hope you have installed LT Spice. If you have installed, type Y in the chat box. Those who have installed the LT Spice, I shared one PPT with you. If you have installed, type Y in the chat box, please. Which diode need to be, any one of the diode, Dr. Niket Sastri, you can use any type of any diode from the list you can select. Okay, all of those diodes actually listed in the list, the simulator will work. 4001 is one most commonly used. So if you have done the LT Spice, let us start the LT Spice experiments. Sanjay ji, are you here? Sanjay ji. So the next session is taken by Mr. Sanjay Bagaria. So he will introduce you with the LT Spice and related experiments. Mic is disabled. Okay. Dr. Geeta, can you help Sanjay to make him presenter? Give me just 1 minute, I will be completing it. So just give us 1 minute. We are connecting back.
Yes, ma'am. No. Okay, he should unmute. Yes, ma'am. उस lab he has to take the lab. उनको problem आ रहा है. He is trying to connect. Already presented मैंने बना दिया. Now I think he is trying to see.
हो गया इसको छोड़
But नाम क्या उनका?
नहीं उन्हीं का संजय
संजय. नाम कैसे दिख रहा है? हाँ शायद.
पीछे
Okay.
Uh, yes, dear participants, we are back. Just give us a minute. There is some technical issue.
क्या बोला इसको?
So yes, dear participants, we have shared you a document related to spice, and this document was actually shared to help you how the LT spice is actually installed. What is LT spice, P spice, H spice, NG spice? These are actually the tools which are especially used for the circuit simulation. Spice means it is simulation program with integrated circuit interfaces, and these are the variants like LT spice, P spice, H spice, NG spice. So some of the versions of these are like H spice is the paid version, LT spice, NG spice, P spice. These are actually the free version, open source version. So you can download on your systems. If you have lab, you can download in that, and then you can start, right? So that's the thing. Yes, Sanjay ji, please proceed. So how it is going to work? Basically, there are user-defined circuits using the netlist. Spice uses models to simulate the components. It performs the DC analysis, AC analysis, and the transient analysis. DC analysis means it is the steady state analysis. You are going to give the fixed voltage, let's say 1 volt, 2 volt, like that. AC analysis means the input is sinusoidal, triangular wave, square wave, pulse type wave, or something like that. Transient analysis means time varying analysis it is going to give you. In AC analysis, you will be finding the phase and frequency related response also, like phase margin, frequency margin. You might have studied that you will be finding in the AC analysis. Next, please. So netlist spice the circuit description. For example, here the left hand side the circuit is given, and the nodes are denoted by 0, 1, 2. There are only three nodes, so 0, 1, 2 is the numbering which we have given. Now the input file is actually the netlist we are supplying. The right hand side you can see demo of a simple AC circuit. So V1 is supplied between 1 and writing the name of the source, that is V1, 1 to 0, and what is the source type, it is, and then this is 12 volt, and this is sine wave. Okay, so next one is R1. So R1 is between 1 and 2 terminals, and its value is 30. And next to it we have C1, the capacitor. So this is between 2 to 0, and its value is 100 micro. We have to do the AC analysis, AC linear 160, and then we are putting 60. So this is the frequency we are going to make it, and then print AC V2. V2 means at second node we want to check the output voltage. So you can see analysis at frequency 60 hertz, it is V2, magnitude is given, magnitude and phase, all these things are given. So I request Sanjay ji, please take a demo from this actual the can actually do hands-on practice. So we have shared this document with you. You can please go through it, and it is going to be helpful for you to understand what actually the simple program Spice can. You can write the netlist and you can generate it. So yes, this is the simple program for a simple IV characteristics of the diode is being taken. So we are going to start it from scratch. Sanjay ji, may I request you to completely start from the new, completely start from zero, like open the software, then go to the file and all these things. So those who have already installed the software, they can actually follow whatever the screen is going to tell. Just follow all these, and if you have any issue, please keep on typing in the chat box. We are there to help you. So Sanjay ji, I will request please start the circuit from scratch. It is already drawn circuit. It might be you can see the DC value is given to the V1 source. V1 source, D1 and R1, these are taken from this menu bar, and then these are connected. There is connecting line, you can see in the blue on the top. You have to connect this. Then select the V1 voltage, select the diode type, which diode you have to take. You have to select all these things. And then related to diode, this is how what type of sweep you are going to have, that you have to take. So it is the DC sweep for V1, and it is starting from 0 to this is the IV character.
हम्म
हाँ हाँ चलो करो.
क्या हुआ?
हाँ मेरी कॉल पे जा रहा है, आप कंटिन्यू करो, ठीक है.
Am I audible? Yeah. We'll start with this new circuit. Let's open the new file. Load resistance. As like in the virtual lab we are doing, the similar fashion we are doing in the workbench circuit. For example, we are plotting the VA characteristics of the diode, then this one is the ground. Now just click the right here and then give the value, let's say 5 volt, and the load value, let's say 1 kilo load. And now we are going to run the system. And now we are doing the DC analysis that the current flowing through the diode, the voltage across the diode, in the similar fashion that we are going in the virtual lab. So the voltage sweep we are going to do C source, and the name of this source is V1. We have write the V1. The sweep will be the linear, and now we are starting from 0 to 5 volt with an incremental step size of 0.01. Now we are going to plot the VA current flowing through the diode. So this symbol will be the current flowing through the diode. So just it is being plotted. Now the VA characteristics will be the voltage across the diode and the current across the diode. So this is varying 0 to 5. This is the supply voltage. Now we need to connect a voltmeter. That means the potential at this node minus potential at this node. For this, I have to define the node name. Let's say in the circuit, we have defined this the node name is 1, 2. In the similar fashion, we are going to define the node name. Let's say this is the netlist name. Let's say it's a Q node. But this name of the node is just Q, and the another node, let's say it's a X node.
संजय जी थोड़ा धीरे बोलो, लोगों को समझ में नहीं आएगा. थोड़ा हाँ धीरे
ಇಲ್ಲ
धीरे बताओ
அது
कम हो जाएगा
ஏழு
बट कम से कम उनका एक
நிமிஷம்
एक्सपेरिमेंट पूरा हो जाए दैट मैटर्स
செஞ்சு
राइट
வச்சுட்டு வந்துட்டேன்
सो
ஆமா
स्पीक
4
स्लोली
மணிக்கு போயிட்டு வரேன்
या आराम से
4 5
This
அந்த
node will be the Q and this node will be the N.
நிமிஷம்
So we need to just click right here, then again run,
இப்போ
and then click right,
போடுறேன்
and then instead of V1, this is the supply voltage. We need to define the potential at node Q. So V of Q minus
ஆமாம்
V of X.
ம்
This will be the potential at node this
ஆமாம்
minus potential at node this. Then okay. It will be plotted like the VI characteristics of the diode. Now you can pick up any
நடுவில்
kind of
நான்
diode. Let's
லஞ்சுக்கு
say
போகிறேன்
this is a large variety of
Lunch
diode
with the
available there. So it's a different manufacturer, the different saturation current, the doping concentration, all of this variant. So we can select any country depending upon our requirement and then change the characteristics. They all have different 80, cutting voltage, breakdown voltage, and all these things. So this is the simple
எனக்கு
VI
தேவையில்லை நான்
characteristics of
அது நல்லா
ordinary
போயிட்டு
P
வரேன்
injection diode.
संजय जी
So we
there is a question uh, Mr. Yuvraj Singh want to ask how the voltage is set voltage how the voltage is set he is having the
ஒரே
question
ஒரு நிமிஷம் இது ஹோல்ட்
how the voltage is set.
yes
சொல்லு
and your screen is not visible now I think yeah now it is visible
You can change this set voltage. This really doesn't impact. Let's say I'm changing it 1 volt.
இங்கே
So it
நிறைய
will not impact the system. The command which I have given, that is the dot DC V1, that is varying from 0 to 5 with an incremental step size of 0.01.
so you have to describe yes you have to describe from where you have given this command
அப்படி இல்லை இங்கே
Okay. When was, let's say I'm starting it from again. So let me delete this command. Okay. So when I start running, there will be some options like in the starting slides we have shown that which kind of analysis we are going, like transient, AC analysis, DC analysis. In this particular analysis, I am going to do the DC analysis. So I am varying this supply voltage. The name is V1, and I am varying it linearly, starting from 0. And let's say now I am varying to 3 volt with the incremental step size of 0.05. Okay, so it will be giving like curve like that. Point.
Yuvraj Singh ji you got the point Mr. Yuvraj you got the point
Okay, I will do it by another.
yeah
Exercise for the Zener diode. Take the Asper diode. Let's do it. Let's say take a diode here, different configuration, magnetic resistance, and then again voltage source. The circuit. This will be the ground point. And make a resistance, let's say this time, okay, 2 k. Okay. Now right click on the diode, pick a new diode. So all these types are so it's a silicon Schottky diode. So we need to plot the characteristics of Zener diode. So we have to select the Zener diode having the breakdown of 6.2 volt. So I am going to select this diode. You can select any of your choice. This is the Zener diode symbol. Now this is the voltage. Let's say I am given 2 volt. And this potential has been overridden by the dot DC command. Okay, so just run it. And now this is V1. Again, the name of this voltage source is V1. So again, I am writing it's a V1. Again, I am varying it linearly. Now, previously I started from 0. Now, this time I want to plot the VI characteristics in reverse bias also. So, and the breakdown voltage of this diode is around 6.2. So let's say I am starting it from -10 and dropping it 3 with the incremental step size of 0.01. Then okay. And also this time for this circuit, we have 2 different nodes. Right? For this circuit, the potential at this node is always 0. So I need to define only one node. Let's say
அது 1.5 மாசமா வந்து இருக்குது
Sanjay ji, Sanjay ji, can you copy paste the things in the chat box, because people are saying that it
எப்பதான்
is
வரும்
not visible,
சீசன்
the screen is small and the values are even small. So if you can type in the chat box if something
15ஆம் தேதியிலேருந்து
related to
வாங்கிடலாம்
this, like the strap size is this,
15ஆம்
like
தேதியிலேருந்து வாங்கிடலாம்
my chat box is disabled.
no, chat box is, mic is disabled, chat box is not disabled.
ஆஹா
Able to read.
Okay. Okay, tomorrow we will just sort it out. So, Niket ji, what we can do is, he will be speaking a little bit slowly, and please try to catch it.
So this is the first question, that how to set the value sign is okay.
சரி சரி
Let's say. So for this circuit, I am knowing the breakdown voltage is 6.2 volt. So I will set it more than that. Let's say I can also set it minus 8. Or you can say let's say minus 7.
நான் என்ன
It
வேலை
either it will be a PN
இருக்கேன்
section diode or a Zener diode. For the
தெரியல
volt, cutting voltage will be around 0.7, 0.5. So I can set it let's say 1.5 also. And this will be the incremental size. Let's say you are going to plot a curve like this.
இரு நான் சொல்றேன்
If I'm giving you the point like 1 and 2, so
இங்கே
you
கூட
will be able
நல்லா
to plot like
பாருங்க
only
இதெல்லாம் ரொம்ப
straight
பெருசா
line. The
இருக்குது
number of points are more. So the curve will be more precise.
இங்க
So
பங்கன
this
பள்ளி
is the
நல்லா
incremental
இருக்குது
step size. Let's say I'm decreasing
இல்ல
let's say
இல்ல
0.1.
உத்தரப்பிரதேஷ்ல வந்து பங்கன பள்ளி வருது
Okay. And then define our node here. Let's say
அது ஒண்ணு ரெண்டாவது அதுக்கப்புறம் அந்த
this name node is correct. And then run that.
தசேரி லங்கடா அது
Putting the correct. And then right here, bigger rotation at node U of R.
வச்சுக்கிறாங்க இன்னும் 2 மாசம் 1.5 மாசம் ஆகும் அது வரது
Look like this. If I increase the step size from 1 to 0.01, the graph will be more precise. So the origin line, this 0. Yep.
இப்போ இரு அப்போ சரி சரி பாருங்க சரி
6.2 is because of
Ah.
breakdown voltage and this
அம்மாவுக்கு
is
ரொம்ப
the
வேலை
circuit
கொடுத்துருக்காத
you can observe the difference of plotting the PI characteristics of this ordinary PN junction diode as well as the
எதுவும் பைப்பு தூக்கி போடு
Zener
நல்லா
diode
கிளிக்
for
பண்ணி இந்த
forward
வேலையை
and reverse
கொடுத்தாரு
bias.
சரி சரி
Unnecessary any conference.
அது இன்னும்
Please type the things in the
இன்னொரு
chat box
டாக்டர்
if you have any questions.
அதான் நரம்பு வீக்கிறது இன்னும் போகணும் இன்னொரு டாக்டர் பார்க்கணும் ஆப்ரேஷன்
Do you have any questions so far? Please type in the chat box. So there are no questions.
இது பண்ணக்கூடாது
Should be another example.
Yeah. You can start from the scratch again. Like for the simple diode, you have not taken from negative, so the reverse bias is not actually shown. So that example maybe, because this is double diode and capacitor, maybe they cannot understand right now. Some of them cannot understand. Of course, faculty can understand. So simple, maybe what you can do, simple RC circuit you can take, and then just go through the R, maybe DC transient and AC and DCs. All the things. So keep it at slow pace. Keep it slow pace, because the screen and your voice, both of these are actually delayed. So keep it at slow pace. RC, make it RC instead of simple R, because it will verify the strong slow. RC will become a filter, right?
Okay. I am giving any value, let's say 3 volt. Now this button to the DCC. The name of this source is T1. I'm going to make it increasing linearly. Starting from, let's say, minus 10, going up to plus 10 with the incremental step size of 0.1. Now this will be the symbol. This is the Ohm's law. This is the origin line. Are you anyone able to work? Now the question is how we are going to change this. Now I'm going to change anyway. Let's say I'm going to change it. Let's say minus 5 to minus 6. The characteristics will be okay. Now, what if I am going to introduce a diode in between that? So let's take a diode. Press Control R, make it rotate. And then the G-net diode. Let's say this time I am taking it a breakdown 4.7 volt. Okay. So this 4.7 is the minus 5 is greater than this, and then 6 volt. And the step size of 1. Now I'm going to plot it. So, and I need to define a 2-node name. So just click on the net list, name this node, let's say E node. Then name any node, node E, then node. Okay. Now run the system. Then plot the characteristics of the baseline will be the V1. But instead of that, we need to click right. Then potential at node E minus potential at node. This will be the characteristics of. So 0.5.6 is around the cutting voltage. 4.2 will be the breakdown. Is this thing clear, or should I go to other more examples?
संजय जी आप अपना स्पीकर बंद कर दो, कुछ इश्यू होगा तो मैं बता दूंगी. उससे इको आ रहा है, स्पीकर बंद कर दो आप. Yes. Please type Y in the chat box if this is fine. Please type Y in the chat box if this is fine. Yes. So you may proceed. You may proceed, Sanjay ji.
Proceed with another examples for voltage doubler, or let's say voltage doubler, that means it's double the input voltage. Let's say it's a simple. In this, we are going to do the transient analysis. So this will be the voltage source. Just instead of giving values, write 1 volt or 5 volt. I am going to give it a
Your screen is not visible now. Yeah, it's visible.
Okay. So I am going to give it a let's say sine volt. Just click on the, let's say for this, just click on the voltage and click right. Then go to advanced options. Make it sine. Let's say voltage will be 1 volt. Frequency will be, let's say, 2 kilohertz. Okay. In the similar fashion, I have defined this voltage. Okay. So this one is just capacitor, drop down, then capacitor, and then diode. And the frequency, this is the offset is 0, amplitude is 10, frequency is 1 kilohertz. And I am taking the output here. So this is the voltage doubler that I am giving the 10 volt, and I am getting the output is a 20 volt. Let's run the system. This will be the output. So this blue curve, that is the blue curve V of B, potential at node B minus potential at node A will be the minus 20 volt. And if I reverse it, let V of A minus V of B will be the plus 20 volt. And this red color will be the input sinusoidal signal. Let me do it with another examples. For example, let's say I am taking it as a diode, making the resistance R, right? That's it. Go to advanced options, giving it a sine voltage and amplitude, let's say 2 volt this time. Frequency, let's say 1 kilohertz. So for 1 kilohertz frequency, the time period will be 1 millisecond. Okay. Now define the R, let's say 5 kilo ohm. Now run the system. So previously we are doing the DC analysis. Now this time we are doing the transient analysis. So we are simulating the circuit for the 5 cycles. Let's say 5 milliseconds. 5 time is millisecond, and that one cycle time period is 1 millisecond. So we are simulating it for the 5 cycles. Okay. Now we are taking the output here, and this will be the main. Let's say, and I'll click add plot. Are you able to know it? It is a similar kind of rectifier type of circuit. This blue color shows the input, and the green will be the output circuit. Is this clear?
Please
Is this clear?
type in the chat box if you understood this. Type Y in the chat box.
Like the input.
If you could understood it well, please type in the chat box Y.
We can change the polarity. Let's say just rotate it, and now just again remember. So the polarity that output waveform will change. Let's say output waveform will going to change. Or let's say do another exercise. Like I am going to place another back-to-back diode. Will be something like a square wave. Something like a square wave. Or we can do more complicated with this. Like connect a battery. More space will be required. I am just moving this, right? Let's say 0.5 volt. 0.5 volt I am connecting the battery here. Now again I am running the system. So the value is being changed. Let's say I am showing the battery value is 0. The waveform will be looks like 600 about like 600 millivolt will be the cutoff voltage of both the diode. So it is being oscillating between plus 600 millivolt and minus 600. Now I am making it a battery. Let's say half volt battery I am connecting. So the value of oscillation will be changing in negative direction. From positive minus 600 to this value is being changed. Let's say changes at minus 1 volt. The value will be going to changing like that. Now you can further more complicate this circuit by connecting another battery and make a polarity in opposite direction. this value, let's say I'm giving it a 5 volt. Now run the system. The waveform is being vanished because this waveform diode is always being in reverse bias. So only one diode will be working. Now change this value to let's say half volt. So the waveform will again fade. Yes. So we can do such kind of exercises, and by introducing this capacitor, the whole system become a clamper circuit, that is the shift in the output voltage. So up to this, is this concept clear to everyone, or you need any more explanation? Or
Please type Y in the chat box if you understood whatever is being covered. Two back-to-back connected diodes in parallel, and then the batteries are also being connected. This is the clipper configuration. Clip means clipping away some of the unwanted portion of your input waveform is known as clipper, right? You might be studying different variants of the clippers. So this is one of the typical configuration where both sides of the waveform are clipped away. And these DC supplies, yeah, please proceed.
uh, resistance, we need to make a capacitor again and then connect the circuit. Again, the capacitor, let's say 100 micro input, minus earlier, give it let's say 1 volt, frequency let's say 500, and make it as a here. Now I am running, then I need to simulate let's say 3 milliseconds. This will be the input cycle and this will be the output cycle. So there will be a motion, there will be a clamping. Then change the configuration. The kind of system. In the similar fashion, I have designed a voltage doubler. It doubles the output voltage. This is the circuit of voltage doubler. Means 10 volt. Let's say I am giving it as a 1 volt. 1 volt. So the output volt will be 2 volt. Potential at this node. Let me run this system. This will be the output. Similar kind, you can simulate any circuit. Should I continue?
Yes, is there any question so far? Dear participants, is there any question? So I think we have completed ample number of examples for today, and tomorrow there is one lecture at 9 a.m. Then another session will be from 10 to 12. After that 12 to 1 session we are going to postpone because I have some official work which is having much more priority. And after that the class from 5 to 7 is also postponed from 6 to 7:30. So now we are open for the questions and answers. If you have any questions and answers related to whatever we have covered so far, you can feel free to type in the chat box. We are here to answer you about it. Also, we have uploaded the 2-day video recorded lectures on the Canvas platform. So if you can access it from there, you please let me know if you are able to access those from there. Just type Y in the chat box if you are able to access the video lectures from there, video recordings from there. Oh, great. Why double Y? Okay. Recording saving. Okay. Yeah, thanks, Dr. Geeta. We have done for the day. Question answers are